the time to remediate findings. So recording in progress. Okay. A reduction in the time to remediate findings in there. So we did see that. There's more buy-in, they understand the importance of fixing the vulnerabilities that have been discovered, hence there's a reduction in the time it takes. Just one second. So what are some of the unexpected observations that we have seen? So when you first start out on your program, you're going to be discovering a whole lot of vulnerabilities, right? Your SAS, your DAS is going to pick up all these things because those tools were never there before. So you're going to get all these issues, findings coming in, and your teams are going to be spending a lot of time trying to address the security issues. What you would expect is with time, as you are going through the backlog and addressing the outstanding issues that are in your system or in your applications, you shouldn't be introducing any more new findings in there. And that is because, your SDLC program, or your SAS, DAS, SCA, and the coding training and all, teams or developers should be discovering this while they're developing and preventing these vulnerabilities and issues from getting to production. However, what we found is that regardless of that, we're still seeing a lot of time spent on fixing security remediations, a lot more than we expect. So still a hefty, significant amount of time being spent. I think it was about 30% of engineering effort was spent on that. And that kind of surprised us. So we dived into it a little bit further and we kind of went, hey, what are we actually doing? And we discovered that most of the engineering effort was actually spent on fixing CVEs. So these are actually the open source common vulnerability ratings, right? So having a lot of time that was spent on that. And we went, wait a minute, that doesn't seem right, because we've shifted left, right? We have an SCA2, we are preventing our developers from introducing third-party libraries that have vulnerabilities in there. But what we found was that all the CVs that were coming in were mainly new CVs in existing components. So these are components that had no security issues at the time when they were first introduced, but then there were security issues after that. And the time that we spent were actually not just on fixing it, but it's all about dealing with backwards incompatibility. We get there's a new version, bumping that new version up breaks something else. We got to fix all that. And that was what we found ourselves spending a lot of time in there. That made me realize that, hey, the existing process that we have in our SDLC, the SCA, wasn't really shifting security to the left. We were still playing whack-a-mole. We were saying that, hey, there is no CVEs or any known vulnerabilities at this point in time. But then going forward, we were just waiting for them to pop up and then we would address them. And that took up quite a bit of engineering effort. So that is what I would say the blind spot is. So if you guys there was this report that came out quite a few years ago. Well, not actually, I think it was maybe 2 years ago. So this is the State of Software Supply Chain report. Take a look at it if you haven't read it yet. It's a very good read, very interesting. You can find it easily, just Google for it. And it says that it is quite rare for organizations to write the majority of their software in-house. And it says that most organizations will leverage open source software to create the bulk of their software application. That report put a number in there, and it said that 85% of modern applications comprises of open source software. 85%. So that meant that all the stuff they were doing, the SAS, the SCA, the training, that covered only 15% of our application. So when I read that, I was like, hey, I'm going to do my own analysis. And I did the analysis on some of the apps within my organization. So for one of the apps, we had 12 components that were written in-house. So this is a Java Maven application. So this 12 components consisted of submodules and internal libraries. Now, how many open source libraries do you think the application uses? 50? 100? It uses this many. It had 268 open source libraries. So for that particular application, 98% of it is actually open source. Now, hey, let's not just look at the numbers, let's actually look at file size. So the in-house ones was about 504 kilobytes, and the open source was about 86 megabytes. And it was still about 98%, or maybe it was even more. And I found similar ratios with the other applications that I analyzed. So what this tells me is that our development team only writes a very small percentage of the code that makes up our application. So who is responsible for writing the bulk of our application's code? Who develops open source software? So open source software could be developed by individuals, right, who devote their spare time, working in the evenings or on weekends on this. Most highly successful open source software are not developed by a single individual. So you could have multiple of these individuals working on the project together. There could also be contributions by developers from companies who volunteer their company's time to contribute to the open source. So I think the main big ones are Google, Microsoft, and Red Hat. And on top of that, most open source software also leverage other open source software. So open source is actually, the people who develop it is a very highly distributed team of individuals and companies who are working together, probably remotely too, using other open source software. And as a result, I would say that it is quite complex. Now, you can't do a talk without talking about last year's Log4j, right? So this is a very interesting article that came out that says the internet runs on free open source software. Now, who pays to fix it? And it came out right after the Log4j incident that came out there. And I think, like all organizations, when that came out, it always comes out, at the worst possible time, right? I think it was on a Friday leading up to Christmas. Everyone was scrambling, organizations were kind of trying to understand what was their exposure, what open source software are we using it, which applications are impacted by it, which appliances we have in there. We were spending a lot of time trying to understand, trying to mitigate it. But while we were doing that, Vulcan here, he's a Log4j maintainer. He was working 22 hours a day for free to address the Log4j vulnerability. He is one of our developers. He's in our team. He's our development team. We depended on him to release a non-vulnerable version of Log4j so that we could keep our applications safe. Now, I think it's great that we have people like Vulcan who contribute their time in there. But do we have the confidence for the other open source software that we are using? For the ones that I looked at, 98% of our software is open source. Can we say the same about all the other components, that if there was a vulnerability, one of their developers would step up to help? I don't think so. This is very interesting. I like this quote. It was from one of the developers at Google who actually does a lot of open source work. And he says that volunteerism is unsustainable for critical infrastructure because volunteers are well within their rights to only work on the fun or interesting parts of the job. They're well within their rights. And he also said that an open source project also needs careful testing, release engineering, issue triage, security reviews, code reviews, and all of this, a maintainer may find some or none of these aspects motivating in themselves. I'm not sure if any of you have, contributed to open source before. I remember many years ago, I helped create a few WordPress plugins, and I was like, hey, this was fun. I was doing it for my own hobby site, made it available for anyone to download. And I kept it running for about 3 or 4 years, and then I gave up. Because what happened was, what worked for me on my website, I had a lot of people complaining to me about, hey, it's broken, or we'd like some sort of feature request. And after a while, it wasn't as enjoyable anymore. And hence, I could relate to those comments in there. I felt like it was well within my rights to only work on the things that are fun and interesting. And because I was running it on a non-critical system, I didn't do any testing. I didn't do any security reviews. There was none of that. And because of that, I would say not all open source are created equal. For our organizations, yours and mine, we have development processes in there, right? We have secure coding practices. We make sure that everyone does the training in the OWASP top 10 so they understand some of the common vulnerabilities. We do integrated testing. We check not only for common bugs and unexpected behavior, but we also check that there are no changes that may have been made without the developer's knowledge. We've got change control, and we also got two-factor authentication or multi-factor authentication for our developer accounts or any important account that is associated with the project's design, deployment, and maintenance. We're doing that for the 2% of the code that makes up our application. Do we know if this is the same thing that's being done for all the other applications or all the other open source components which we depend on? Now, I don't think so. I'd like to talk now about some of the more recent open source breaches that we have seen, right? This one is probably one of the more recent ones. I guess it's not as recent anymore now. That's the Spring Shell, right? The 0-day RCE that came out. And things like this do happen. I mean, even for the things that we write, we can still put vulnerabilities in there unknowingly. But one of the challenges with open source is in that same day, proof of concept exploits get released. So we need to move very quickly. How quickly are we notified when there is a CVE or a 0-day in one of our applications or one of our open source components? And then you've got this kind of vulnerabilities in there. For this particular article, it's about an NPM package, it's been poisoned with crypto mining. And this was because the developer's account got compromised. And this is a very common thing where the developer's accounts or their SDLC process gets compromised and gets broken into. Clearly, they either reused their password, didn't have good processes in there, or they didn't have 2FA. Now, do we have the confidence that the systems or the other open source that we're using are prevented from this or are protected from this? Are the developers having good security practices in there? I'm not sure. This next other breach did not involve compromising accounts. Now, it works based on developers not realizing the typo in the library's name and picking the malicious library instead of the legitimate one. So it's typo squatting, right? Those malicious jams originated from this two main user accounts. The one I want you to pay attention on is the one on the top right, Atlas client, because it has a very high number of downloads in there. So now here's a screenshot of the legitimate library next to the malicious one. Do you remember which is the malicious library? It's the one at the bottom. And it turns out not many people could, because if you look at the downloads, at the time when the incident was reported, the malicious jam had close to 30% of the total downloads. Now, what are we doing in our organizations to protect ourselves from this? Would our software composition analysis scan, the SCA, our open source library scanning, would they pick this up? Or would they just say, hey, this Malicious Library, we just don't know about it. It's just unknown and we don't do anything about it. Do we have any controls to protect against that? Now, here's one that's starting to grow in popularity. I call it open source activism or protestware. So this particular user made this post late 2020, and I'll read it out to you. It says, respectfully, I am no longer going to work for Fortune 5000s with my free work. There isn't much else to say. Take this as an opportunity to send me a 6-figure yearly contract or fork the project and have someone else work on it. And early this year, this happened. You know, developer corrupts NPM libraries, colors and fakers, breaking thousands of apps. And the developer is the same developer that made that comment earlier. And this wasn't a situation where the developer's accounts got compromised. It wasn't typo squatting. It was essentially the developer knowingly, consciously adding an issue in there. This, you would say, is more like a malicious insider, because this person who writes open source that you use is technically one of your developers in there. So he added this thing called the new American flag module, which if you are not familiar with it, it runs an infinite loop and it obviously breaks your app. And that doesn't look like an American flag, but who knows? But you might say, hey, we don't use this particular library. But what happens is other libraries that you use, like in this case, the AWS Cloud Development Kit was also impacted. Because like I say, open source also leverages other open source in there. How are we protecting against this? There was a more recent one, I think that just came out in March, and this is similar thing, protestware, NPM package. The developer released a change in there. There was a sabotage version. And this was the protest that ongoing Russian-Ukrainian war, right? Where I think it looked at the IP address on the developer's machine. And if the machine originated from Russia or Belarus, it started deleting files on the system and started creating new files in there with peace messages. What are we doing to protect ourselves from this? So hopefully I kind of shed some examples on some of the issues in there. And I don't think you and I are actually doing enough to protect ourselves against this. We're not shifting left on this. We're actually reacting when this comes out. And usually when we do that, it is a little bit too late. So now I'd like to talk about how do we address this gap? What can we do about it? So the first thing that we should do is we need to have a dependency list. We need to have what they call an SBOM, a software bill of materials. Now, your applications are mostly made up of open source components, and you need to have a way to keep track of what those components are. Why do we need to do that? So that it allows us to quickly respond to open source vulnerabilities when they are discovered. And it helps you to quickly understand what your company's exposure is. Like when the Log4j came out, was your company going, hey, we know exactly what's impacted and how we're impacted, or were you just scrambling trying to figure it out? You need to have a dependency list. And this is so important that last year, the White House issued an executive order for improving cybersecurity. The importance of managing that was so important that it called it out again just last month. Now, I like to refer to this as the what's in your water. When you go to the shops, you go to the grocery store, you always have the ingredients list for all the things that you buy, so you know exactly what's in it. Like for this, it's purified water. But is it really purified, or are there other things in there? So same thing, treat your open source software or your applications like that, and your open source the same. You need to know what's in it. The second thing that we should be doing is we need to have better due diligence on all new dependencies. Now, I am very surprised at the different processes that organizations have for software that is open source versus commercial software. Let's take a look at what the difference normally is. So if it's an open source software, how do we go about picking open source software? So the first thing we do is usually the developer assesses the software, right? And the process that they take is they'll go and do a search to figure out what to use. It could be based on past experience. Hey, I could have used this in my last company. It was a long time ago on my last project. It could be the first entry from your Google search. Do a search, it comes out in there. It could be a response from Stack Overflow. Lots of votes in there, must be good. So you pick that out. That developer goes in there and they assess the software. What is the criteria that they look at when they're assessing the software? There's only one criteria. Does it work? When I run it, does it do what I think it's supposed to do? And if it does, what do I do? You ship it, right? You commit the changes, push it into the master repository, and it goes in there. And that one developer is usually the decision maker. You might have two. If you have the code review process in there. Now, let's compare this to what happens if you need to spend $1 on the process. So if you need to spend $1 or more, you now have to go through the procurement process, right? How does that look? How does that normally look in your organization? So first, you need to put a business case. You need to assess the software, right? You need to do multiple comparison against different alternatives. Because that helps you to put your business case out there. Usually there's a group of developers working on that. Once you've decided that that's the one that you want to pick, what do you do next? You get an assessment done, right? You get security involved to do a risk assessment or a risk review on that, and security will ask a lot of questions in there. Hey, they will ask things like, hey, what sort of data is it handling in there? What kind of data we're putting on that software? They'll ask things like, what is the software development processes that they have in there? Is there any external attestation that this company have? Are they ISO 27001? Are they SOC 2 Type 2? Do they do a pen test in there? Can we see a pen test report in there? After that, if that's all good, you then go to the contract review. Legal would say, hey, let's look at what's in the contract. Are there any terms and agreements for what is the SLA for them to fix any vulnerabilities in there? Obviously, I'm going for both extremes in there, but I'm sure that most of our organizations fall somewhere in between. But what I want to drive is that there's more due diligence being done when we are about to spend $1 or more on a software. Why is that so? Is it because there's more risk with using commercial software than open source software? No, I don't believe so. But yet, for most organizations, there is a large discrepancy in the way we review free software and paid software. And I've heard that in some organizations, the open source selection process is like the Wild West. Anything goes, just pick it, run it through. If it builds, you're good. It should not be the case. You should ask some questions before you use open source. And here are some of them. The first one is, do we really need this? Are we already using an open source software that does the same thing? Now, you don't want to have 5 different libraries doing the same thing. You want to pick one, and you want to pick the best one out there. You want the highest quality product in there. Is this software actively developed? Now, an actively developed software is not an indicator that it would still be supported in the future. However, software that's no longer actively developed, that's a pretty good indicator that you should avoid using it. The next one, is it popular? And the idea behind this is that popular software are used a lot more, and hence it gets a lot more scrutiny. As such, any vulnerabilities in the software will be found quicker as compared to if it was not as popular at all. What license does it have? Now, that's not security specific, but it's a very important thing to ask. And the last one, are there any known vulnerabilities in the software? Now, you do not want to pass defects or security issues straight away in there, because we already know that it's going to be a lot more work to fix something that's already in production. So we want to prevent it from going to production straight away. So these are the questions that we should ask. Now, I know you're going to say, hey, Edwin, you just showed us that the last application, there's 268 open source software. How the hell are we going to ask those questions for each of those 268? How can we scale this? And there are ways you can do that, right? You can put that in your SCA tooling. And there's this tool down here. It's called a security scorecard by the Open Source Security Foundation. You can integrate that. I think there's GitHub Actions that integrates into it. And it actually does all this for you in an automated way. So you can build that in there to quickly do the checks. On the screen right now, there's a bunch of checks in there. Pick what's important for you in there. Is the contributors important? You need at least 2 different groups of contributors in there. SaaS important, that they need to have SaaS scanning in there. You can automate all this stuff today. And the last thing that you should start doing is you should update your stale dependencies. We always say, always build on latest. A dependency is considered stale when there is a newer version available. Now, using the newest version means that you have the latest bug fixes and security fixes. And if you don't keep up with your dependencies and be running on the latest all the time, they can very easily get stale, and you have problems when you need to upgrade with backwards incompatibility. Breaking changes in open source software is a huge problem that we face out there. It's in that report, the state of software supply chain. So it is a lot easier if you're on the latest version already to be maintaining that. There's a few ways you could take to do this. One is, whenever teams are working on the software itself, to make sure when you make a change in there and you update, everything is on latest. The other thing you could do is you could dedicate it. You could have dedicated time each month where teams would go through the applications that they look into and upgrade the versions in there. You're getting free open source software to allow you to move fast, and this is the tax, the maintenance price you have to pay to make sure that they are up to date. And you could automate it. On this screen is Dependable. There's lots of other ones in there. This is one of the first ones. It's built into GitHub. I think GitHub acquired them, which helps to automate that. But one of the challenges is that for this to be successful, you need to have confidence in your automated testing. So once you have that, you can automate all that. So to summarize, third-party management is the new application security blind spot. And there are 3 things that you should do to address that gap. The first one is maintain a software bill of materials. Second one is make sure you perform due diligence on any new dependencies, any new open source software that you're introducing in there. And the last one, always build on latest. Make sure you update your stale dependencies. And what we always do in my company, we always ask the question, what's in your water? And with that, thank you very much, guys.